So volts denoted capital letter V. So these are the three main actors in electricity: current, voltage, and resistance. So kune inonzi Ohm's law inotiudza the relationship between current, voltage, and resistance. So let's look here. Ukanzi state Ohm's law kuti unoti kudi Ohm's law states that current through a conductor. So current, remember current yakafanana water that is passing through pipes. So current through a conductor is directly proportional to the voltage. So about current and voltage in a direct proportion. Zvichireva izvo kuti voltage ikawedzera current inowedzera. Andidika? Kana kuti current ikawedzera voltage inowedzera zvekare. So remember, this is coming from Ohm's law. There's a guy called Ohm who studied this, that the current through a conductor is directly proportional. So what's important is directly proportional to the voltage across it, provided temperature remains the same, constant. So temperature has to be the same. When you do these measurements at temperature, let's just say it's 50 degrees Celsius, and you do the same measurements at 100 degrees Celsius, then you are going to realize that there are going to be inconsistencies. So temperature inofana kuramba iri constant for this to work. So what is the limitation of this law that says the current through a conductor is directly proportional to the voltage across it, provided temperature remains constant? The limitation is if a conductor is put in a strong magnetic field. Saka ma measurements aya pakaita a magnetic field close, then our measurements is kuti the current is directly proportional to voltage. Zvinobva zvavhiringika. You might not realize a direct proportion kana ma measurements akaitwa in a strong magnetic field. The other thing that you can think about is that temperature itself is a limit. If the temperature is not the same, then again Ohm's law is not going to be obeyed. So we have a strong magnetic field and also temperature. These are limitations of the Ohm's law. When a strong magnetic field is there or temperature is changed, then Ohm's law is not going to be obeyed by the measurements that we take. So Ohm's law, you can also write it as an equation. You can say resistance. Ohm's law can be written as resistance is equal to voltage divided by current. We can use I to represent current. Resistance is called voltage over current. No mathematical formula yacho ya Ohm's law. Or you can state it in words to say that the current through a conductor is directly proportional to voltage across it, provided temperature remains constant. Kanzi equation ya Ohm's law, this is the equation. So this equation can be changed. We can rearrange it for voltage. Voltage is equal to, the cross multiply, voltage is equal to it's R over 1, so V times 1 is equal to resistance times current. Ri, resistance times current, no voltage. Then ndikada kushandisa Ohm's law yo ndokwanisa kuishandisa for current. Kuti current saka apo ndakudivide both sides na R. So current is equal to voltage divided by resistance. So no three equations that one from Ohm's law by rearranging this first formula here. So limitation part of the strong magnetic field, magnetic field, but also remember that temperature is also a limit. When you do the measurements without keeping your temperature constant, then Ohm's law is not going to be obeyed. Second one is Ohm's law, and there's a diagram that we use to measure Ohm's law. I will share the diagram in a different video. Yeah, so let's look at this question. Fig 5.1 shows an electric circuit with 3 resistors. So remember resistance, kuna anonzi ma resistor, and ma resistor, if we want to show them on a diagram, triangle is a rectangle like that. So that's a resistor, that's a resistor. So we have 3 resistors there, and R1 is 2 ohms, R2 is 2 ohms, and R3 is 6 ohms. So state the way in which R1 is connected in relation to R2 and 3. Saka tukuti isusu, we are looking at I am a resistor maviri, right? Tichima compare ne iri kuti connection yacho yakaita inonzi kudii. Saka connection yekuti we connect things next to each other like this and running in parallel like that is called parallel connection. Andika? But then tikati R1, R2 versus R3 connection inonzi series. So R2 is connected in series with R3 whilst R1 is connected in parallel with R2 and R3. So you have to know kuti parallel ne series connection. Parallel, it's next to each other, and in series it's one after the other. This is series. When you look at this versus this, it's parallel. Okay, so it's important to appreciate my connections iwawo parallel na series. So let's just write this down, that here the way R1 versus R2 and 3, this is parallel. Okay, right. But if R2 and R3 parameter series, these are in series, one after the other. All right. Calculate the total current in the circuit. Now, to calculate total current, what you can do is you can try to think of my formula edai. So I know current E. Current is equal to voltage divided by resistance. And so we are given the voltage there. And then my resistance takapiwa ima resistor akawanda. So tofana kuza kuti kune formula yeku calculator inonzi total resistance. Saka total resistance pano ne panapa inenge irichi. What is the total resistance? Remember, in our water analogy, the water is trying to come, then you pinda panapa, you pinda panapa, and my resistor are could resist the flow of this water, which is our current. So we want to know what is the total resistance that is experienced by the water. What is the total resistance experienced by the water? So we are thinking per point yakaita say E kuti what is the total resistance. So tine effect ya R1, R2 and R3. So how do we calculate the total resistance? So kana akadaro, kana are in series, you just add. So in series, what do you do? Add. Kana are in parallel, unoti wewe for resistors in parallel, you say a product which is you multiply. Let's just say you multiply first, multiply their values, multiply, then divide by the addition of those numbers. What are we saying? So this is for resistors in what? This is the rule for parallel. So we have two situations here. Two situations. Panapa tina both parallel and series, and it. Saka tutanga tadila ne aya in series. Ma tina R3 na R2 na 3, and it R2 hands in the 2 ohms. Panapa tina 2. Then panapa tina 6. Saka tumbo tanga ta add 2 and 6. Total resistance here R2 and 3 is what? Is 8 ohms. Is 8. Saka remember this 8. So it's like we have one big 8 ohm resistor, which is this big. This is our big 8 ohm resistor. This big 8 ohm resistor is connected in parallel to this small resistor, whose resistance is how much? The resistance of this one is 2 ohms. Sakatani situation here parallel pama resistor maviri anoti R1 and this big 8 ohm resistor. Sakata akuya situation formula yedu. Since they are in parallel, let's multiply the numbers first. What are the numbers? We have 2 and 8. So 2 times 8 is 16. Divided by, let's add the numbers. 2 plus 8, that's 10. So when we divide those two, we're supposed to get 1,6. So the total resistance of those 3 resistors becomes 1,6. So this is what we have to do here. So let's check our answer here. So donya iripo nofana tanga wadila ne so pana batati ma resistors okay, R1 is in parallel with R2 and 3. So these are the calculations. First get your series and then you do your